Alright, so the first concept we're going to work on is this equation that I had you copy last time, okay? And it's a certain type of problem that you're going to have to learn how to do. It's a problem that asks you to find consecutive integers when they give you a total, okay? Focus now. Consecutive integers means integers that are in a row. They follow a numerical order, or they follow a numerical pattern. Sometimes they're right in a row, 3, 4, 5. They can skip and be like 3, 5, and 7 consecutive even integers, or consecutive odd integers. Alright, that's enough. Get focused now. Open your notes. Open your notes. We're on lesson 7-2. And so these are numbers in a row, okay? What we'll do is assign the value n to this, and n will be our first integer in the row. And so if we were to find, if n is the first one, then n plus 1 is the expression for the second one. N and n plus 1. Okay? Brett, get focused. And then n plus 2 is the next one. Skipping, adding 2 to the first one. Okay? Guys, stop whispering. You're not listening. You're not listening, you're not concentrating. Okay? Listen to what's going on. How are you going to learn this if you don't listen?
Bryce, put your hand down.
Well, okay.
I can learn from my dad.
That's not a question. All right? And Bryce? Yeah. I'll talk to you after class, okay? So, this is the expression for the three integers, n plus 1, and n plus 2, okay? Now, if we were to add these together, if it says the sum of the three integers is 96, for example, they'll give you what the sum of the integers is. And then you have to put these together, adding them together to figure out what n is, and then figure out the three integers. So, go back to this in your notes. Go back to this in your notes. And highlight this problem. And it's specifically this equation. Highlight this right here. Okay? Now, why is we add these three together? This represents the first integer. Emily, Tyler, focus here. This highlights, this is the second integer in a row, and then this is the third integer in a row. Okay? And then you simplify this by adding these like terms, which is what we've been talking about in this lesson. N plus n plus n. We have three n's. That's where this comes from. And then you can add the numbers together. 3n plus 3.
Plus 2.
1 plus 2 is 3, Brett. And then we know that this is equal to 96. So now we have an equation that we can solve. 3n plus 3 equals 96. Amanda? How would we solve that? 3n plus 3 equals 96. You know? All right, and listen, okay? What? Yes. Yep. How would we solve this, Emily?
So you start making the side of the variable, so we plus negative.
Yep, we have to get rid of this number first by adding its negative, by adding its opposite.
And then on the left side it's 0, and then on the right side it's -3. And then you have to get n by itself.
So wait, first then we bring this down, 3n plus 0.
And then you want to get n by itself, so put it over 3.
Then we have to simplify this, and that equals 93.
And then you do 3n divided by 3. And then you do it to -3.
Yep.
And then
What is this number called, Jeremiah? Yep, what is that number called? What is the 3 called? That's the number in front of a variable. It has a specific name.
Coefficient?
The coefficient, yep. This is the coefficient. And so when we divide the coefficient by itself, you get
N.
1,
1 N.
and you have 1n. Yep. And that equals n. And you have to do the same thing on the other side. You have to divide both sides by the same number. So that gives us the answer for what n is. Now, we have to use this value to find the 3 consecutive integers. So what are the 3 consecutive integers then?
N.
First, you go back to the expression for these integers. N plus 1, and n plus 2. So if n is 31, what is n plus 1? Ariana? And n plus 2? Lydia? 33, and we've got the 3 integers in. Okay. How do we change the expression if it said that we have to find 3 consecutive even integers? What if it said we have to find 3 consecutive even integers that equal 78? What would you do then? How would you change, instead of n and then n plus 1 and n plus 2, how would you find 3 consecutive even integers? Or how would the expression change? Brett?
So you would have just N, and then the next one would be N plus 2,
Correct.
and then N plus 4.
Very good. Yep. So if n was 0, n plus 2 would be 2,
Yeah.
n plus 4 would be 4.
Yeah.
Or if n was 10, it'd be 10, 12, and 14. So these are the expressions we use. Now how do we find the numbers? If it said the sum of 3 consecutive even integers equals 78. Now what would you do? The sum means they're all added together. So now write this equation. Write this equation using these expressions. Go ahead and do that in your notes. Write the expression using these, or sorry, write the equation. What would go on this side for if the sum of these 3 consecutive even integers equals 78?
Yeah, I don't know.
Sum means to add. Look at what you highlighted for the equation for consecutive integers and use that same form. But instead of n plus 1, and n plus 2, use n plus 2, and n plus 4. Did you write it out?
I did.
Where is it?
Can we have a worksheet so we can kind of like read the top of it?
So this is what your equation will look like then. The first number plus the second number plus the third number would equal 78. Okay? This is the first integer, this is the second integer, and this is the third integer. 3 consecutive even integers. Okay? Put them all together. They equal 78. Now, how do you simplify this? Tyler?
Oh wow.
Yep. So how would we simplify? What would the simplified form of this be? Yep. 3n plus 6 equals 78. N plus n is 3n. And 2 plus 4 is 6. So we simplify this to 3n plus 6. Now what?
Oh, get it.
Oh, you have a question,
Oh,
Bryce?
is it not connected? That's why.
Oh, I
Instead of
didn't
all the
see that.
ends and all
It's
that.
like n plus.
To each of these n's,
Yeah.
the first n represents the first number that we're trying to find.
Okay.
And we're trying to find 3 numbers that when you add them together, they equal 78. We know that these 3 numbers are consecutive even integers.
Oh, I think I have a question.
That's how we know that the next one is n plus 2. Because a consecutive even integer, as an example, would be if the first one is 2, then the next one is 4, and the next one is 6, as an example. Okay? So it's all based on the starting number. The starting number is the one we're looking for first. Once we know the starting number, then we can find the others. Now, how do we solve this?
How we solve it?
Yep.
So we're gonna do a plus -6 on both sides. To get rid of the 6.
Shh, everyone shut up. He's about to mark
Be quiet.
And then, so you can get 3n plus 0. And then you just have 3n.
3n plus
Why is he?
I don't know. Strike 3. Page 365.
Oh my.
44.
Alright, please be quiet and listen now. Cole, you were explaining what we need to do to solve this. What's the next step?
The next step is to get 3n by itself. So you can do plus -6 on both sides.
Right.
It would be 3n plus 0 equals 72. And then you divide by 3 on both sides. And you get n1. And then it's n equals 24.
Yep. So what are the 3 integers? Daria, what are you doing?
Looking for a Kleenex.
What?
I was looking for a Kleenex.
Okay. So what are the 3 consecutive integers then? Bryce, do you understand how to find the 3 consecutive integers now?
Yeah.
So this first one is 24.
Yeah.
What would the second one be?
26.
Yep, 24, 26, 28. Does everyone understand why these expressions work? So what we're trying to do is find the starting number. If the starting number is 24, then if we add 2, it's 26, and if we add 4, it's 28. It gives us the 3 consecutive integers. Jen?
On the extras that we have, is it page 350 or 360?
360. Okay.
No,
All right.
no, we have.
Go to your book and open to page 359 and do numbers 8 and 9 right now. Page 359, 8 and 9.